about how your sample size interacts with your interval. When you have your interval, it gets built from finding the margin of error. So if we think about finding our margin of error, how does the margin of error come from the sample size and the other numbers involved? How do you find it? If it's assuming large sample, but this would apply in both of them. Close? Okay, so this is the formula, and what I'm saying is I want to tell you what size E I want, what size the margin of error is going to be, and you're going to have then a confidence interval. So if I said 95th, you could find the Z, and then I'm going to tell you the standard deviation. I want you to work backwards and figure out what N is. And if I did this multiple times, we know that it's a lot handier to solve an equation for the variable you want rather than having to resolve it every single time. So if I were to give you all of the other letters and you had to figure out N, how could you change that equation so that it would actually pop out N when you plugged in numbers? What would I do backwards? Like, what would be my order of operations? What would it look like? Okay. So far I've got E over Z sub C, and that would equal standard deviation over square root of N.
Standard deviation equals N times the...
Yeah, you'd have to have this being multiplied to get it out of the denominator. Okay, so you said standard deviation equals E, I've got the square root of N over Z sub C.
Wait, would it be, no, question, would it be that way? Are you sure, or would it divide first, then go?
E over Z sub C times.
Because the N is technically being divided by Z sub C.
That's true.
That should be, that would be the square root of N. Because you divided Z sub C, or first, and it'd be N.
You divided it away, but then you were choosing, because this square root of N was in the denominator, that's why you had to multiply it, because if all I did was move the standard deviation, I'd still have 1 over.
Yeah, I know that, but I'm just saying, like, N should be divided by the Z sub C.
It could be next to it. I mean, I could write, whoops, well, I could write the problem where, like, the square root of N.
Is this under E?
It wouldn't be underneath, though.
No, under, no, under
Yeah,
E.
it could be, like, over here.
Yeah.
You want, okay. Because you know, because it does mean the same thing, but I see what you're saying. As far as looking at it, you want N by itself, so it might help you to look at it like that. What would you do next to get N by itself?
Oh, you want N by itself?
Mm-hmm.
Well, you can minus the standard deviation.
Standard deviation's already over there.
Oh, you just take the whole thing, you're times by Z sub C, or Z sub E, and then divide by E.
Yeah, and you could do that all at once if you wanted, thinking about, like,
So it'd be
you're saying multiply by that and divide by that.
So it'd be standard deviation times Z sub C, divide by E,
Okay.
and then N by itself.
Square root of N is by itself.
Oh, the square root of N, and then you do the square.
Good. So N is equal to, you said Z sub C and a standard deviation over E,
Square.
all of that being squared.
You know, you could have just times by N and then divided by E.
Well, that would have given it 2.
Okay.
She's saying up at the very beginning, when it was this line. Now, you could have multiplied by, you said E? Oh, multiplied by square root of N right off the beginning on both sides, and then divided by E. Oh, and then squared it.
Why didn't you tell us when we were just doing all this stupid stuff?
I was going to watch her and see what happened.
Well, good news is we got to the same answer. Who cares how we get there? So the benefit of this formula is if I gave you those other variables, you wouldn't have to resolve every time to get the N by itself. So if I were to say find a minimum sample size, of course it could be bigger because we know that our approximations only get better and better as the sample size increases. You told me that my interval would get smaller, so I would be able to figure it out better and better. But if we go through this, we say find the minimum sample size. I want to be 95% confident. I'm looking for N. What would be my Z sub C if I want to be 95% confident?
What would it be? 99%?
Look for it.
Yeah, look
Would it be underneath 9?
Yeah, jump one. Be underneath 9.
Oh, we're not going we're not going off of, this is a Z sub C, this is a large sample, we're assuming.
So it's that one.
Oh, so it's a normal one, so it's like
Yeah.
1.6 inches.
Yep, you're really close.
It's like 1.6, 1.96.
Okay, so I'm gonna use the 1.96 coming from that. And then I'm supposed to multiply by the standard deviation. It told me in the problem here, the population mean standard deviation is 53. And then I'm supposed to divide by E. E, remember, is how close you want to be. It's your margin of error. So that's where in the problem it says I want my sample mean to be within 10 units of the population mean, meaning I want to be 10 on either side.
Question.
Mhm.
The standard deviation, since it's sample, is that, do you get to do that square root, or is that, yeah, that's never mind.
Oh, did I have to? No, yeah. I would do all that work and then I would square it.
Because I thought you had to switch to the standard deviation and sample. But then I forgot which things.
Yep, good memory.
Sample.
Put that in a card.
Are we all just waiting for each other to type it in?
Yeah, because I don't want to.
Oh, you want me to do it?
I don't even have a type.
Somebody, what'd you get, Ben?
I got 107.91.
Oh, I think she's.
Okay. So this is a sample size, which refers to numbers of people that I need to sample, or numbers of items that I need to sample.
I think it's 107.
Can you sample 107.9 of something, or of people,
Yes.
or items?
Yes.
No.
Yes.
Not last I checked, I sample an item or I don't.
Nope.
So why would 108 make sense, even despite the fact that it's a 0.9, and so it would round to 108? What if it would have been 107.4?
It would have been
You can't
107.
have 0.4 of it.
True, but should you
Well,
round
you
down?
can't have.
No, that's the bit you'd be missing
But I
out.
have a question.
Yeah, if this is a minimum, you're always going to need to round up. I don't know if this is people. Yes,
You're saying that you can have point something of something?
0.7 of an, like I can't sample it 0.7 of a time. Because this is the actual number that I take in my sample. So if it was people, for example, I couldn't survey you less than one of a time.
What?
Like I couldn't survey you half of the time.
Oh, I was just asking.
We did agree the other day that even babies were people.
Oh,
People.
I wasn't here, so I don't know.
Forgot that babies were people.
Babies are not people.
They're whole person. So this question, what this question does for you is it tells you if you want to be a certain amount of closeness to an actual answer, it tells you how many people you're going to need to sample. So that way you can make sure you're at least that close to being correct, or at least 95% confident that you're that close. This is coming up in those questions.